Hello dear students. In the previous session, we have discussed about introduction of complex numbers and some of its real life applications. In this session, we'll discuss about real and imaginary parts of complex number, purely real and purely imaginary complex numbers, zero complex number, equality of two complex numbers, and finally some important notes on square root of negative real numbers. Now we'll discuss about real and imaginary parts of a complex number. For the complex number z is equals to a plus ib, here a is called real part of the complex number z and it is denoted with the real part of z, and b is called imaginary part of the complex number and it is denoted with imaginary part of z, and we know I is square root of negative 1. So let us take one example. Z is equals to 2 plus 5i. In this, real part of z is equals to 2 and imaginary part of z is equals to 5. Now we'll discuss about purely real and purely imaginary complex numbers. For a complex number z is equals to a plus ib is called purely real if b is equals to 0, that is imaginary part of z is equals to 0. For example, z is equals to 5. It is a purely real complex number and this is called purely imaginary if a is equals to 0, that is real part of z is equals to 0. For example, z is equals to 5i. This is purely imaginary complex number. Clear? Here you need to understand this can be written as 5 plus 0i and this can be written as 0 plus 5i. Clear? So z is equals to 5 is purely real and z is equals to 5i is purely imaginary. Now zero complex number. A complex number is said to be 0 if both real and imaginary parts are 0. That is, z is equals to 0, which is equals to 0 plus i0. Here a is 0, b is 0, which means real part of z is 0 and imaginary part of z also 0. Then only you say the complex number is zero complex number. Clear? Now equality of two complex numbers. Two complex numbers, let z1 is equals to a plus ib and z2 is equals to c plus id are equal if a is equals to c and b is equals to d. Then we say that z1 is equals to z2. In other words, when z1 is equals to z2, then a is equals to c and b is equals to d. Now let us solve some examples based on equality of complex numbers. Here is the example. Find the values of x and y if 4x plus I of 3x minus y is equals to 3 minus 6i. Here these two complex numbers are equal, which means according to equality of complex numbers, this part is equals to this and this part is equals to this. So 4x is equals to 3. That implies x is equals to, here 4 is multiplied by x, if it comes here divides 3 upon 4. Here we got x value, that is 3 upon 4. Now the other part, 3x minus y is equals to negative 6. 3x minus y is equals to negative 6, and we know x is 3 upon 4. Substitute here, 3 into 3 upon 4 minus y is equals to negative 6. Further, 3 3s are 9 upon 4 minus y is equals to negative 6. Further, negative y is equals to, if you bring this 9 upon 4 into other side, it becomes negative. Negative 6 minus negative upon 4, and taking LCM 4 6 are 24, negative 24, negative 9, which becomes negative 33 upon 4. Both sides, when you multiply with negative, negative gets cancelled. So we'll get y is equals to 33 upon 4. Therefore, x value is 3 upon 4 and y value is 33 upon 4. Here is another example. Find the values of a and b if 2a plus 2b plus I of b minus a is equals to negative 4a. Here you can see in the right side, this is purely imaginary. So this can be rewritten as 0 minus 4i. So which means these two complex numbers are equal. That is 2a plus 2b plus I of b minus a is equals to 0 minus 4a. We know that this is equals to this, both real parts are equal, and this is equals to this, both imaginary parts are equal. Further, if you equate real parts, that is 2a plus 2b is equals to 0, which is equals to, take 2 common, a plus b is equals to 0. Here 2 is multiplied by a plus b, if it comes here divides, 0 upon 2 is 0. So a plus b is equals to 0, then a is equals to negative b. Here we got a condition. Now, so on equating imaginary parts, b minus a is equals to negative 4. And from this condition we have a is equals to negative b. So we'll substitute here. That implies b minus negative b is equals to negative 4. Further, b, negative of negative positive, b plus b is equals to negative 4, which is equals to 2b is equals to negative 4. And dividing both the sides with 2, 2 1s are, 2 2s are, then we have b is equals to negative 2. So we got b value. Then a is equals to negative b, then a value will be a is equals to negative of negative 2, which becomes positive. So therefore a is equals to 2 and b is equals to negative 2. Now here we'll discuss about some important notes on square root of negative real numbers. If a is a real number, then square root of a negative real number, that is square root of negative a, which is equals to, this can be rewritten as square root of a into negative 1, and further we can rewritten as square root a into square root negative 1. We know square root negative 1 is I, so I square root a. So which means square root of negative a is equals to I square root a. Second one, if any of a and b is 0, then square root of a into square root of b is equals to, you can rewritten as square root of ab, which is equals to 0, because if a is 0, 0 into b is 0, square root 0 is 0. If b is 0, 0 into a is 0, square root 0 is 0. And third one, which is very important, that is square root a into square root b is not equals to square root ab if a and b are both negative. Clear? So we'll discuss more about this. We already know square root a into square root b is equals to square root a into b for all positive real numbers a comma b. This result also holds true when a is greater than 0 comma b is less than 0, which means A is positive, B is negative, and A is less than 0, comma, B is greater than 0, which means A is negative, B is positive. But this result false for A is less than 0, comma, B is less than 0, which means when both are negative, this result doesn't hold. Now let us consider I square. Consider I square, that is I into I. We know that I is square root negative 1. So which is equals to square root negative 1 into square root negative 1, which is equals to square root of negative 1 into negative 1. This is by assuming square root A into square root B is equals to square root AB for all real numbers. Then this can be rewritten as square root negative 1 into negative 1, 1, and which is equals to 1. So let us take this is number 1. And we know the fact I square is equals to negative 1. Let us take this is number 2. Now from 1 we got I square is 1, and from 2 we got I square is negative 1, which is fact. Therefore 1 and 2 are contradiction to each other. Therefore square root A into square root B is not equals to square root AB when A comma B are both negative. Now let us discuss some examples based on previous results. Here is the question. Evaluate square root of negative 16 plus 3 into square root of negative 25 plus square root of negative 36 minus square root of negative 625. So this is nothing but square root of negative 1 into 16 plus 3 into square root of negative 1 into 25 plus square root of negative 1 into 36 minus square root of negative 1 into 625. And further we know square root 16 is 4, so 4 into square root of negative 1 plus here square root 25 is 5, 5 3s are 15 square root of negative 1 plus square root 36 is 6, square root 36 is 6 square root negative 1 minus square root 625 is 25 square root negative 1. And we know square root negative 1 is nothing but I, so we'll replace. Then this becomes 4i plus 15i plus 6i minus 25i. Further 4 plus 6 10, 10 plus 15 25, 25i minus 25i, which is 0. So we got 0, that is 0 complex number. Clear? Here is another example. Find the value of square root negative 25 plus 3 into square root negative 4 plus 2 into square root negative 9, and which is equals to 5 square root negative 1 plus this becomes 2 3s are 6 square root negative 1 plus this becomes 3 2s are 6 square root negative 1, because square root negative 25 can be written as negative 1 into 25 and square root of 25 is 5. Similarly the other terms, and replace square root negative 1 with I, then this becomes 5i plus 6i plus 6i, this becomes 17i. Clear? Here it is another example. Simplify square root negative 9 into square root negative 4 plus square root 2 into square root negative 8. So this can be rewritten as square root negative 1 into 9 into square root negative 1 into 4 plus here we can rewrite this 2 into negative 8, square root 2 into negative 8, because this is positive, this is negative. So here we can apply square root a into square root b is equals to square root of ab, but here we can't apply because both are negative. Then further square root 9 is 3, 3 into square root negative 1, square root 4 is 2, 2 into square root negative 1 plus 2 8s are 16, negative 16. Negative 16 can be rewritten as negative 1 into 16. Square root of 16 is 4 into square root negative 1. Further, we know square root negative 1 is I. So we'll replace here 3i into 2i plus 4i. This becomes 3 2s are 6. I into I square, and we know that I square is negative 1. So this becomes negative 6 plus 4i. So the value of this is negative 6 plus 4i. Clear? In the next session, we'll discuss about algebra